So thanks for coming out. Again, I want to thank our sponsor, DataZoo, who's sponsored in the past pizza and beer and has this great facility for us. I'll let them speak. And please pay attention to this. This really can't happen without them. My living room is far too small.
I'm Australian, that's why my accent is strange. Woo! So I'm Beth Logan, I'm the VP of Optimization at DataZoo. What that means is I run the data science team, we work on algorithms for our business. So if you don't know who DataZoo is, we are a software company. We build programmatic software for marketers who are running ad campaigns on videos, on websites, on mobile apps, and even now on TV. So it's all pretty cool. And our philosophy is to automate everything we do. So that's where my team comes in. There's a lot of automation. We use a lot of cool algorithms, including we use Spark actually in our production system to process all the data and then generate machine learning models that then bid in real time with real money on ads on behalf of our customers. So it's a little bit boring for me to say that we are hiring. We're always hiring. We're a pretty big company actually. We're about 350 people. Boston is our headquarters. You're in it right now. We have a couple of floors here. And we have about 100 engineers or so. So there's plenty of things for engineers to do, product management. And if you want to have other friends who want to do other things, just check out our website. You can see all the jobs we have there. So I don't want to take up too much time unless the speaker is delayed. Okay, there's more slides. All right, so thanks for coming and enjoy yourself.
I don't have many slides, so again, thanks to DataZoo. The next meetup is going to be July 2nd at Optum. They have a really, really nice office. You can see Fenway from it. The two speakers are going to be one's from Swoop, Simeon, and then there's another guy. I don't remember his name. He's from Streamlio. So that'll be on Monday, the first week of July. So there's already about 50 RSVPs, so try and come to that one as well if you can. And if you ever want to speak or sponsor, please get in touch with me. We're good for we'll need speakers for September. And then Spark Summit is coming up. It's also been rebranded as Spark Summit, PipelineAI. If you're interested, there's a promo code. I don't actually know how to get it. I was just told there's a promo code. But it's going to be a pretty good conference. There's over 3,000 people already signed up. I'll be teaching if you're interested, or you can just harass me at the booth there. There's a lot of different talks. Some are going to be better than others. But it should be interesting either way. All right, so I'll introduce first Chris. So his bio he wrote, and he'll probably do a much better job of introducing himself than I would. So I'll hand it up.
Wait, so you're speaking at the Spark conference? You're doing, which class are you training? Yeah, which class are you doing?
I'm doing the ML on Azure.
Oh, are you?
Yeah. It's brand new material that I've never seen, so it should be exciting.
Yeah. It's like all the rage now. Yeah, let's say, so probably 60% of our customers at Pipeline are on Azure, which I didn't know going into this business that I was going to end up back doing Microsoft stuff. But there's actually quite a bit more than I thought. Right, like, do you guys use Azure? Anyone here use? Really? It's not quite 60%, but anyone use, what was the, is it like Joyent or whatever? Yeah, anyone use Joyent? Yeah, yeah, of course we did. Okay, so this presentation is 260 some slides. And I think one or two of you have already seen this because you just came from Open Data Science Conference. Oh, and it still says Open Data Science Conference. Sorry about that. Who saw my talk? I think it was last year. It was at EchoNest. It was the same meetup. Spotify/EchoNest. Because it's a totally different talk, by the way. But all right. So my name is Chris Brinkley. Started this company, PipelineAI. I actually worked at like IBM. Where's Trevor? Trevor works there. You used to? Still do?
Used to work there.
Okay. And yeah, I was part of the Spark Tech Center back then, so that's my connection to the Spark world. I run this meetup. It's called the Spark Tech Center. Or Spark Tech Center. The Spark and TensorFlow meetup, the Advanced Spark TensorFlow meetup. So I started this meetup. I was actually at Databricks. And was a bit frustrated where all of the like meetups and the community stuff ended up being sales pitches for the Databricks product. And so I was kind of annoyed. It was right when I was leaving and joining the IBM Spark Tech Center, so of course IBM fully embraced this. They were like cool with it. The Databricks folks weren't really. We're at 10,000 people in San Francisco specifically, and then 75,000, actually I think that's probably more than that. We have about 15 chapters, so there's a lot of material. That's my point. We have that YouTube channel and SlideShare. I think if you go to pipeline.ai, there's a community tab, and all of, there's thousands of hours, there's thousands of slides and hundreds of hours of presentations. I've been doing the meetup for about 3 years now, and today's mostly going to be about TensorFlow, and the high-level reason for this is I can't talk about Spark anymore. After working at Databricks and being part of that community, I just can't do it. But the other reason is, so TensorFlow is very production-focused, right? Whereas our Scikit-Learn, like MATLAB, these kind of things were like designed for the lab. They weren't really meant to leave the lab. They were kind of there, to point to batch data at best, big data. And with TensorFlow, there's a lot of like real-time stuff that's part of it. Like, we don't really think about this, but I'm going to highlight some of the real-time aspects of TensorFlow. So I was telling the people at ODSC that I'll be here. Has anyone come from ODSC? A couple people? Yeah. Oh yeah. Yeah. Like, were you at my talk too? Yeah. So you'll be pretty bored. All right, so are you guys familiar with this concept of hyperparameter tuning, like what this means in general? So whenever we're learning or fitting a model, we're trying to learn parameters. But then there's hyperparameters that help learn those parameters. So that's why they're called hyperparameters. And hyperparameters are typically specific to a model. So it would be like tree depth, things like this, right? If you're trying to figure out or train a decision tree, there's going to be certain characteristics about that algorithm, and these are called hyperparameters. And so most people, when they think of these hyperparameters, they're thinking about offline, and by offline I mean pointing to an S3 bucket, pointing to HDFS, but there's more than just these offline hyperparameters, right? There's certain online parameters that we can actually tune once the model has been pushed to production. So I'm going to highlight those. Also, I'm going to talk about ways to push out models quickly. So I have a Netflix background, not just binge watching. Which actually I watched less Netflix at Netflix, than I did now. The thing, so I'll tell a story later, like a funny story about. Yes, I had sample data. My sample movie was Harold and Kumar, Go to White Castle. That was always in my sample data set. And then we started going global. I was part of that whole disaster. And Harold and Kumar in Europe, or in, I think it was England area, London was one of the first. They actually changed the name because they don't have White Castle in that part of the world. So, all of a sudden, all my tests were breaking, because apparently I was hard coding my tests to Harold and Kumar, Go to White Castle. So that was my first experience with international expansion was, make sure, they called it Harold and Kumar Have a Fun Night or something like that. I think they still have the White Castle logo, but I guess no one, if you've never been there, you wouldn't pay attention to the logo. Talking about like getting models out there quickly, being able to compare these models. So, this is something that we did natively at Netflix, and when I joined Databricks, I realized that nobody in the data science world actually does this. Like, this is not like, to give a data scientist access to production, seems like the craziest thing to people. Like, to me, it's, with the proper tooling, this is fine, right? Because at Netflix, we had a badass tools team, that's where Asgard came from, things like Spinnaker, if you've heard of that's like the second generation Asgard. And these were ways so I was on the streaming team for us to get code into production quickly and then also tear it down quickly. So I'm famous for single-handedly taking down North American streaming for about 30 minutes. So someone on our team got fired, as they did every few weeks, and we were forced to rebuild. It was, chaos employee is what we call it. And I had to take over this guy's project, and when I was scanning the code in my head, his configuration was in, I thought it was in seconds. It was a heartbeat type thing. It was the first time we were introducing heartbeats to talk to the Amazon servers that hosted, all of Netflix. And so I pushed this code out, I tested it, I pushed it out, and set it to 5, but that was actually milliseconds. So every single device in North America was pinging the mothership every 5 milliseconds. So that was really bad. But so actually I got a call from my sister whose kid couldn't watch whatever show was on, and she was like my pager duty, basically. Meredith duty. All right, so some key takeaways here. There's also like a bit of like multi-arm bandit stuff we'll talk about where we can dynamically shift traffic. So, again, this is things that we sort of took for granted in our earlier generations. So me and my team, where we could shift traffic based on any metric. And one cool metric to shift traffic on would be like cost per prediction, right? So we spend a lot of our time at Pipeline dealing with models after they've been trained, and then sort of tying all that together, like how is the model doing in production? It's sort of an area that is not well engineered right now. And so the ability to shift traffic quickly based on how these models are doing, and just like having insight into how these models are doing is super important. And then there's this sort of explainability aspect to it here, where we're starting to see more and more ensembles now. So these ensembles are multiple models participating in a single prediction. And it's a little bit of a regularization type technique where you don't want one model to dominate, so you want to combine a bunch of models. But there's also this explainability aspect to having multiple smaller models that feed into the prediction. Because now, the smaller you get, that model was trained on a specific set of data. You can kind of tie it back, right? These neural networks are not very well known for explainability, but if you can compose smaller models, then you can get a little bit closer. And so some of our PipelineAI stuff, which is open source, you can actually trace, if you're familiar with Zipkin and Jaeger and that kind of stuff, you can actually trace how that prediction happened. All right, this is just a key takeaway thing here. We'll also talk a little bit about continuous model training. So does anyone do this now, actually? So the continuous model training is the ability to update those parameters that you've learned. So not the hyperparameters, but the actual weights that you've learned. You can actually update those in real time. Now that's not always the best thing. I'm trying to think of a funny Netflix. So when I moved to California from Chicago, I discovered this weird holiday in California that's called Ski Week, and it's where the entire state of California just takes off a week. And it's not quite spring break, or it's kind of a forced spring break. And so I discovered this because all of our, I was on call that week, all of our charts, our normal patterns of what we call starts per second. That's the number of times people are pressing play per second. That stayed constant, like in the morning. And, normally that goes down because people go to work, and it was actually going up because kids were home. And so I couldn't figure out like what was going on. That was my point. Oh, and so for like continuous model training, if you're learning at such a fine-grained time interval, right, you'll start to think that that's normal. And that's, and so that's the kind of that's the higher level business reason why you wouldn't want to necessarily train continuously. Anyway, so this is the open source thing. I have a funny story here. We started looking for funding the end of last year, just because we wanted to see how that was going to go. We were doing a little A/B testing on the fundraising front, and at the time we had 2,000 GitHub stars. And we were talking to a pretty prominent VC, yes, Andreessen Horowitz, and they said, that's the second we were talking here. They said, if you have 2,000 stars, that's worth $3 million in seed money to us. And so that was the first time we had actually heard somebody put a dollar value. So of course we quickly started all these campaigns to get people, we have demos now that are based on clicking the GitHub star and all kinds of stuff so we can get that up. So at the time, essentially every star was worth $1,500 in seed money, not in the valuation. Yeah, does anyone know what Brad Ehrlich's shirt says on the bottom right? That says HTML, and it says how to meet ladies. I love that guy. Here's a quick start if you want to go through the pipeline open source stuff. So, like just real quick, at Pipeline, we talk about like productionizing models, and we like certain runtimes more than others. We like certain frameworks more than others. Specifically, we like TensorFlow. We like things like MXNet that are very sort of production first, right? And they give you ways to shrink down the model and like prepare it for fast inference, right? Fast predictions. And the like most basic sort of optimization would be if you have all of your parameters that you've learned, or the weights that you've learned are like represented by 32 bits, and each time you're making a prediction, you have to do a huge matrix multiply, right, like using 32 bits for each float that's in that matrix. That's pretty much going to flood the CPUs, flood the GPUs. If you could drop down to just 16-bit, right, like you get just like an instant like 2x throughput. Because you can put two 16-bit floats into one 32-bit core and like pipeline those together. So things like that you really can't do with frameworks like Scikit and some of those traditional ones. So what we do is we take your model, we actually sort of hydrate it, is like the term that I use. We turn your static model into something that's executable. And it also has the immutable property, so that once that image has been burned, that has like whichever runtime you select, if it has just like normal Python, if it has C, if it has TensorFlow serving CPU, TensorFlow serving GPU, it gets burned in. And that is the unit that's actually deployed from your local laptop to development to production. Okay, so that's kind of a sort of base tenet of the rest of this. And so this actually happens. So I created Pipeline like literally right when like Docker for Mac and Docker for Windows started, right? Like the sort of alphas of those hit, and it just kind of like hit me one day that I can finally take the exact like Docker image on my laptop, run load tests on my laptop, burn that thing, and then promote it through the rest of the system, which seemed completely ridiculous, because we've had Docker, or at the time we had Docker for a while, but it was always on a Linux server somewhere and it wasn't part of my laptop. So that really opened up a lot of use cases. And yeah, the ability to treat that as one single entity. So we have a community edition that's free. It has a GPU. You could go crazy. Yeah, we get a lot of Bitcoin miners on there. So there was someone the other day that was like trying to SS. Yeah, he was if you deploy within a container on like Amazon, right? Make sure that you lock down that like metadata. Yeah, like do you guys know about this? That on like every single cloud instance, you can call this internal. It's like 169 something something. Yeah, all the clouds have it. That will describe the instance that it's on, and that's a very valuable thing until they can get to like SSHDs and get to stuff that you don't expect. So, yeah, like literally having this community edition has like shown me all the different ways people are hacking. Like, yeah, we literally have GitHub issues where we copy blocks of, because we can see the history of what people are doing in there. So it's like a honeypot, if you will. Yeah, are you guys familiar with like Uber Michelangelo? So this was a blog post. Came out in September, and what was interesting about this is it's an internal version of what we've been building, right, at Pipeline. And our stuff is obviously influenced by Netflix, and we have people from PagerDuty, people from NVIDIA, people that have seen these problems. And this like Uber, So this blog post, what's interesting too about this blog post is that these VCs know about this, like in Silicon Valley. They're like, well, how are you different than Uber Michelangelo? Yeah, our response is Uber Michelangelo is Uber. It's not anybody else, right? So we know sort of internally, these platforms are very, very tied to Uber's workflows and to Facebook's workflows, and yes, obviously Google has Google Cloud ML and that kind of thing, but these sort of internal best practices is what we're trying to bring into the community. And then sort of interestingly enough, that's a Netflix job posting that like somebody sent me that's like, hey, you should read this. This actually looks a lot like Pipeline. And I checked back a few months later, and my old boss from Netflix, she had left, did some bad startups, and then came back to Netflix, and she actually took this job. So, and it's literally, if you read the details, it's how to productionize like, machine learning models, how to experiment quickly, how to participate in like the whole Netflix ecosystem already, right? Because Netflix has been doing this for years with the canary releases and the red block and the blue green and all that. But these data science teams, they've never had this capability. The original sort of thoughts on this were from this, this Google paper that kind of references like the credit card, like tech debt of machine learning, and it's that classic thing where we spend 30% or 50% of our time on the actual modeling, and then the other 50 or 70 or whatever is on the infrastructure. So, and actually I'd gone to look for some patents. This was 2 years ago, because Silicon Valley is very patent heavy. Yeah, they really like those things. And any patent searches that I did that were about like predictions and ensembles and kind of managed, like model servers. Yeah, so Google, they have every single combination of every single term that I could possibly think of. It was all Google patents from like 2007, 2008. So yeah, just kind of shows you that these are things people have been thinking about for a while. Yeah, so again, this is all open source stuff. All these frameworks are supported. So this one, my favorite is noflaskapp.com, which we just registered maybe like a month ago. If you've ever productionized any machine learning, you've probably spun up a Flask app, put it behind a Rust endpoint, and you call Scikit-Learn, right? Yeah, who here has done that? Yeah, I've done it, of course. So noflaskapp.com, which goes right to Pipeline, by the way. So there's nothing fancy behind it. It's not Flask. Flask is cool. It's the ecosystem that you're sort of missing out on, right? And you could choose to use Flask and then add in, Grafana metrics and add in like Prometheus metrics, and I see people do this all the time. In fact, we talk with people, right, like initially, and they're like, oh, this is easy. This is just a few bash scripts, and then they come back 3 months later and they're like, oh, this is more than bash scripts. This is like, to get the type of insight into our model predictions, and just the sort of continuous monitoring is actually not trivial at all. So this slide was about 2 or 3 bullet points before I kind of went crazy. I started thinking about more stuff, but there's this concept called training serving skew right? Yeah, but I want to point out this is a like Google term where your model seems well offline and it's really, really high accuracy. And then, but like keep in mind that that was trained on basically historical data, right? Like any data that's not in flight is already old. And now this model goes out, and maybe it's ski week, which is a weird case, but like now this model is just doing horrible. Or right, like what's even worse is over time, this model is not relevant anymore. And there's no way to detect that if you're just spitting it up behind a Flask app. In fact, this guy I met, he was from Apple, and he's like, oh yeah, man, I use Flask all the time. I have my own Mac Mini that someone was about to throw out, and I run it, it's just under my desk. It's an internal machine learning service, so it's not exposed to the public, but he like literally has this thing running below his desk, because it was going to take too much to get the ops guys involved and all that. And there's other teams that are depending on this internal thing, and he's just running Flask, and it's running fine, and I'm like, well, what happens when it fails? And he's like, oh yeah, they usually email me, and then I just kickstart it and all this. And I'm like, well, what happens when it isn't doing well anymore? How do you measure that? And there was no clear way, which is why he was excited about some of the pipeline stuff. This is the CEO from NVIDIA. This is just a couple months ago at the GPU Tech Conference, talking about model inference. So the NVIDIA folks have this thing called TensorRT, and think of it like generating native GPU kernels from your TensorFlow model. So they can read in Cafe, they can read in anything. Well, yeah, not anything, but they can read in TensorFlow Cafe. They can actually generate optimized GPU kernels, and then it's then run inside of their runtime. And so this would actually replace TensorFlow serving, right? TensorFlow serving CPU and GPU. And so this is actually one of the options within our enterprise edition, but that's just a tool. You could do all this with the open source, where you could just pass in fact, I'll show it, the command line, where you say, I want to compare TensorFlow serving CPU. This is all for the same model. Yes, I want to compare just different run times, right? So different chips, but then also different run time. Because TensorFlow serving itself has a GPU version. So yeah, they're really spending a lot of money in this area. It's not just Jetson, like the little portable things, like the drones and all that, but actually data center model serving as well. This is kind of an older slide, but I like it. It sort of frames, there's a lot of people paying attention, and there's a lot of money being pumped into model training. And model hyperparameter optimization is the term. These optimizations are pretty well known, right? There's only a few options. Each model has their own options. Now on the serving side, or the inference side, there's a whole ton of optimizations that have not yet been explored, because data scientists have never had this ability, right, to hydrate their model and kind of bring life to it and change some of those runtime characteristics. Now, one of the challenges we have from our enterprise edition, which I laugh at because I'm a community guy, but is how do we present these knobs to a data scientist? Right?